question 6. So fx equal to negative 3x cubed plus 8x squared minus 9x plus 10. And x can be any real value. So AI, calculate f2. So part A is quite simple, just substitute in x equal to 2 into the equation. So negative 3 times 2 cubed, and then plus 8 times by 2 square, minus 9 times 2 plus 10. So if we put that in the calculator, it should be equal to 0. So if f2 equal to 0, so that means x minus 2 is a factor. And II, write fx as a product of two algebraic factors. So factor theorem. So we need to use the long division to divide it. So since we already know x minus 2 is a factor from AI, so then we can just use long division to divide it straight away. So put this one inside and the x minus 2 outside. So times by negative 3x squared to get negative 3x cubed. So we have negative 3x cubed plus 6x squared. And then minus them, so those two are cancelled. 8x squared minus 6x squared, that would be 2x squared. And then bring down negative 9x and then plus 10. So next one, we times by 2x. So 2x times x will give us 2x squared. And 2x times negative 2 will become negative 4x. So minus them, those two are cancelled, and negative 9x minus negative 4x. So that would be negative 9 plus 4, which is negative 5x, and then bring plus 10. So times by negative 5, we have negative 5x plus 10, and with no remainder. So that means the product of two algebraic factors has to be fx is equal to x minus 2 as one of the factor, and the other one is negative 3x squared plus 2x minus 5. Okay, so using the answer to AII, part B proved that there are exactly two real solutions to the equation minus 3y to the power 6 plus 8y to the power 4 minus 9y squared plus 10 equal to 0. So if we look at those two equations, so we have negative 3, and then 8, negative 9, and then plus 10. So all the coefficients are the same. So the only difference is instead of x, this is y squared. Instead of x squared, this is y to the power 4, and instead of x cubed, this is y to the power 6. So that means all we have to do is just let x equal to y squared. So if x is y squared, that means x squared is just y to the power 4. And if we cube that, x cubed is equal to y to the power 6. So therefore, negative 3y to the power 6 plus 8y to the power 4 minus 9y squared plus 10 equal to 0. And if we apply this, so that will just give us negative 3x cubed plus 8x squared and then minus 9x plus 10 equal to 0. So we can use the result from before. So just x minus 2 times by negative 3x squared plus 2x minus 5 equal to 0. So x is equal to 2, or negative 3x squared plus 2x minus 5 equal to 0, which if we put in the calculator, that would be no real roots. So x equal to 2 would be the only solution. And then because we're looking for y, so x equal to y squared. So y squared is equal to 2. So y is equal to plus or minus root 2. So therefore, we have 2 real roots. So then part B is done. And then part C, deduce the number of real roots for theta between 7 pi and 10 pi to the equation 3 tan theta cubed minus 8 tan theta squared plus 9 tan theta minus 10 equal to 0. All right, so for this one, again, if you compare the coefficients, they're basically the same. Instead of negative 3, this is positive 3. Instead of 8, this is negative 8. And then negative 9, positive 9, 10, negative 10. Yeah. So that means if we times by negative 1 for both sides, so that would be the same coefficient. So which means if we let like tan theta equal to x, then we should have exactly the same as before. So which means we can still use x minus 2, negative 3x squared plus 2x minus 5 equal to 0 to solve it. And then from before, we know this one has no real roots. So x equal to 2 is the only root here. So tan theta equal to 2 is the only root for this equation. And then we know for tan theta equal to 2, it should be only one root for any pi interval. Yeah. So because tan repeated every pi. So that's the tan diagram. Yeah, it's negative pi over 2 and then pi over 2. So it will keep repeat every pi interval. So it only have one root for any pi interval. And then between 7 pi and 10 pi, how many? It's 3 pi. Because 10 pi minus 7 pi is 3 pi. So if one root for any pi interval, then that means there has to be 3 roots for 3 pi interval. Yeah, therefore the number of real solutions would be 3 real solutions for theta more than equal to 7 pi and less than 10 pi. So that's how we answer this. But in the exam, this is just for me to explain to you how it works. Yeah. In the exam, as long as you can spot the pattern and then you say it's 3 real roots, then it's fine. Yeah. This is for explanation only. Yeah. You don't need to write all that to get 1 mark.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.